Let me show you the one idea that turns a chat model into something that actually does the work for you. Not answers questions, does the work. Once this clicks, you'll see every AI tool differently. Here's the part most people miss. The model itself is just a text predictor. You feed it words, it guesses the next ones, and that's the whole trick. Let me prove it. I'll ask the bear model to actually do something and watch it just describe it. So the magic was never the model. It's everything you build around it. The loop that keeps it going, the tools it can reach for, the checks that tell it when it's right. That scaffolding has a name. We call it the harness. And here's the fastest way to learn any of this. Don't go read a textbook. Just ask the tool to teach you. Watch. I'll have Claude explain its own loop out loud and then prove it by opening the file that runs it. See what just happened? It didn't only define a word. It opened the actual file and showed me the loop running underneath. So let me push further and have it draw that loop out as plain steps so I can really see the shape of it. So let's name the engine. A prompt comes in, the model picks a tool and runs it. The result of that tool feeds right back into the context, and then it goes again. Read, act, observe, repeat. That simple cycle is the whole game. Everything fancy you've ever seen an AI agent do is just this loop spinning fast. Let me show you one full turn so it's concrete. I ask a real question. Notice it doesn't guess. It reaches for a tool to go look, and the result it gets back is exactly what tells it whether it's actually done. And here's the thing about that result feeding back in. Each turn, the observation it gets becomes part of the context for the next turn. So the loop isn't just repeating, it's accumulating. It knows more on turn 3 than it did on turn 1 because every tool result is still sitting right there in front of it. Those tools you just watched are the harness's hands. Read and grep to see the code, edit to change it, bash to actually run things. Every single action it can take in the real world is something you, the engineer, chose to hand it. No tool, no hand, it simply can't reach that part of the world. And the set of tools you expose is a real design decision. It shapes what's even possible. So let me just ask it what hands it currently has. And notice how it understands that adding a tool literally grows what it can do. And you're not stuck with the tools it ships with. This is where it gets fun. You can plug in new hands from the outside, a database it can query, your issue tracker, a browser, anything that speaks the protocol. The common standard for this is called MCP. Watch me connect one and let it reach somewhere it couldn't before. Look at what that just unlocked. A minute ago, it could only read files on disk. Now it can ask your actual running database what its schema looks like, and it instantly spotted a missing index. You grew its reach without touching the model at all. That's the whole spirit of harness engineering. Extend the hands, expand the world. Here's a piece of the harness that's invisible but enormous. The instructions you give it up front. Every time it wakes up, it reads a standing brief. In Claude Code, that's a file called claude.md. It's not a one-off prompt. It's the persistent character and house rules of your project loaded into context before a single task begins. And the powerful thing is, you edit that file like code. Want it to always write a test or always explain before it acts? You don't repeat yourself every prompt. You write it down once, and it becomes part of who the agent is. Let me add a rule and watch the very next task obey it. Now here's the biggest shift in how you instruct it, and most people get this wrong. Don't hand it the steps. You don't say do this, then this, then this. The moment you do that, you're back to driving it by hand. Instead, you give it a goal and a way to check itself, and you let it find the steps. That one change is the whole move. But before you let it run, here's a small habit that pays off hugely. Make it show its plan first, one line, before it touches anything. Now you can catch a wrong approach in 2 seconds instead of watching it confidently edit 10 files in the wrong direction. The plan is your steering wheel. So instead of dictating the fix, I ask it to write a failing test first. Think about why that's powerful. The test becomes its own definition of done. It can run at any time and know objectively whether it's there yet. And now I just step back and let it loop. The test runs, it fails, it reads the error, it edits the code, and it runs the test again, all on its own. I'm not in this cycle at all. Watch it close the loop. Sit with that for a second. You never told it the answer. You gave it a way to know when it was right, and it discovered every step in between by looping. That is how you get an AI to operate by itself. Here's a habit that'll make you better fast. Ask it to narrate why it does each thing before it does it. Now you're not just getting a result, you're getting a tutor walking you through real reasoning on your own code. This is the secret to learning through AI. Every task becomes a free lesson if you ask it to think out loud. And you can take this further anytime you hit something you genuinely don't understand. Don't nod along and move on. Stop and make it teach you that one piece, using your actual code base as the textbook. There is no better way to learn. The lesson is about the exact code in front of you. Now hands that powerful need rails, and those rails are part of the harness too. Permissions decide what it may do freely and what has to stop and get your yes first. Watch how it splits a safe action from a dangerous one. Permissions are one kind of rail. Here's another that I love because it takes the loop and bolts hard guarantees onto it. They're called hooks. A hook is plain code that fires automatically at a fixed moment. Say every time the agent finishes editing a file. The model doesn't decide whether to run it. The harness just runs it, every time. Do you see why that's different from just asking nicely? A prompt is a suggestion the model might forget under pressure. A hook is deterministic. It's the harness enforcing it, not the model choosing it. So watch the next edit. I never mention formatting. It happens anyway because the harness, not the model, is in charge of that step. When a job gets big, the harness can fan out. Instead of grinding through everything itself, it spawns subagents, little copies that each take a slice of the work, run in parallel, and report back. Watch it split a repo-wide audit. And then the results come back merged into one picture. You just went from one slow sequential pass to 3 searches at once. And you got that speed up purely by shaping the harness around the shape of the job. Let's put the whole thing together on something bigger than a one-line fix, a real feature that touches several files. I'm going to give it a goal and a check and nothing else, and then watch it move across the codebase on its own. First, it shows me the plan. Now it works across files in one flow. It writes the new handler, wires it into the server, and writes the test that defines success. No hand-holding between files. It's carrying the goal through each one. Watch it lay the feature down. 3 files changed, a test written in passing, and I gave it exactly 1 sentence. That's the harness carrying a goal across a whole feature. You define done, expose the tools, and the journey between files is its problem to solve, not yours. Okay, here's my favorite move of all. Take something it has never done before, give it just the tools and a success test, no instructions, no hints, and let it teach itself the whole operation by poking at reality. This is how you get an AI to operate by itself instead of waiting on you. Watch it figure out a broken deploy from scratch. Notice there were 0 steps from me, just a goal it could test and the tools to go poke at reality. It found the whole operation by itself. That's the difference between a tool you drive and a tool that drives. But here's what really sold me on this way of working. It doesn't have to be right the first time. Watch it form a theory that turns out to be wrong, and instead of charging ahead, the verify step catches it and it corrects itself. The loop is self-healing. And this is the part I want you to really watch. It doesn't get attached to its first guess. The error told it the real cause, so it throws out the theory, reverts the wrong change, and fixes the actual problem. A check it can run is what makes that recovery possible. Without verification, it would have shipped the wrong fix and walked away proud. And before it's ever allowed to tell you it's finished, you make it run its own gate. This is the safety net of the whole harness. A clean test run, a green check, that, and only that is what earns the word done. And here's the beautiful part. When a gate goes red, it doesn't stop and ask you what to do. It reads the failure, forms a theory, fixes it, and runs the gate again, looping all by itself until everything goes green. So step all the way back and look at the 2 ways to work with one of these models. One of them fights the model, micromanaging every move and rerunning it by hand when it drifts. The other one engineers the harness around it, gives it a way to check itself, and then gets out of the way. Same model, completely different results. And you can feel the difference in a single prompt. Watch the harness weigh in action. 1 line from me that bundles a goal in a check, and then it's off running the loop without another word from me. Let me leave you with the recipe I reach for every single time. Just 4 moves. Expose the right tools. State a goal instead of steps. Give it a test to verify against, and then let it loop and correct itself. and the move that ties the whole thing together. The one that'll keep teaching you long after this video. When you're unsure how any of this works, ask the harness to critique your own setup and tell you what's missing. That's harness engineering. The model is the engine. The harness is the whole car you build around it. The wheels, the pedals, the dashboard, the brakes. The engine is the same one everyone has access to. The car you build around it is where all the real engineering lives. Teach it the loop instead of the answer, and it starts to drive itself. And honestly, the best way to lock this in is to go do it. Open the tool, hand it a goal, and a way to check itself, and just watch it loop. Here's the very first prompt I'd type to start practicing tonight. If this clicked for you, subscribe to the AI Engineering series. This is just episode 1. Next time we go deep on what you actually feed this harness and how to feed it well. That episode is called Context Engineering. See you there.